Yes, Hilton, thank you very much for the introduction. Also, very warm welcome from my side. Good morning to the US. Good afternoon to our friends, customers, and partners here in Germany and in Europe. In today's presentation, I'd like to give you some insights on how we run LeanIX at LeanIX, and this mainly focusing on our cloud-native suite. So, as you all might know, LeanIX, and Andre gave some great KPIs earlier this day. So we are having 280 customers today using our platform. In our EA suite, we are managing 230,000 applications of our customers. From the 18,000 monthly active users, we see over 120,000 monthly logins. And we are really fascinated by what our customers do in their workspaces. So they look at more than 50,000 reports in our in the LeanIX product in their workspaces, and they update 1.5 million fact sheets on a monthly basis. So that's LeanIX as you know LeanIX. This is also LeanIX as you know LeanIX. Looking at the screenshots, you might wonder, hey, that looks very familiar. And what you can see is that we remained true to our core beliefs of simplicity and of a clear and easy and intuitive UI. So what you see here is how LeanIX looked back in 2012. There was an inventory, there were fact sheet types. And how LeanIX looked in 2014, you can see a fact sheet. It looks pretty similar. But if we look a level deeper, you can see that LeanIX has made a huge transformation. So coming from a LAMP stack 2012 to 2014, we've started our microservice journey in 2015 and built out all great functionalities into single microservices and establishing a single page app there. So let's look behind the curtain of what LeanIX is today and how LeanIX runs LeanIX. So LeanIX is comprised of 6 product applications running on one platform. In total, we have more than 30 microservices in production today. We have 10 Kubernetes clusters spread across 4 regions. We have 7 development teams in 2 locations, one here in Bonn and the other in Hyderabad in India. And we have more than 65 people working in engineering and product management. So when I joined LeanIX, all engineers still fitted into one office. But this has long changed, and we've built a scalable platform behind LeanIX. So how do we manage our own cloud platform today and make sure that we constantly improve? As we could see in Amy's presentation just some minutes ago, it's about small steps. It's about small iterations and creating value. That's what we also do in improving our own cloud operations using our cloud native suite. So, and the key here is the data that we use. We use data from, for example, GitHub Actions, from Snyk, from Kubernetes, Azure, also Zendesk for our support, and PagerDuty. And we integrate all that kind of information. We contextualize it with a business context and give meaning to it and lifecycle information. In the third step, we look for risks that can be detected in what has been discovered. We allow for prioritization because, as you will see, it's a huge number that you will retrieve from automatic scans. And then starting workflows to collaboratively remove and resolve those violations and make sure that we have a compliant or ensure compliance and good governance and secure cloud footprint. And to say it again, we haven't built that in one day. We did it step by step in an iterative approach. So enriching our data sources, step by step, sprint by sprint to get the full picture and have continuous improvements here. So what I'd like to guide you through today are basically the 4 main objectives why we are using our own products to improve our cloud operations. So the first one is to mitigate the business relevant violations. And as you'll see, a high number of violations come. So the big question is where to focus on in order to secure the system operations, and where can we find a balance between also the fast product advancements that we are aiming for. Second is reducing the time to solution for support cases. As you heard Hilton, the team on my side has grown to 45 people with 65 engineers with 30 microservices. So that's quite a complexity. And it's important that our support agents are finding the right contact persons for a particular microservices when there is a question. And this has become a challenge. So we are using our own product to solve that. Third one is to manage costs in a distributed environment. Also, we've moved mainly to Microsoft Azure. We still got an integration running on AWS. So costs arise in this multi-cloud environment, and we want to make sure that in this distributed scenario, we can make good decisions and balance between user excellence and experience and cost efficiency on the other hand. And the fourth one is we are continuously increasing our development team and the capacity in our development team. So we want to make sure that this keeps efficient. And we've adopted the framework of Accelerate here, as some of you might be aware of. And I will show you how we can track this in the LeanIX workspace and automate it from data sources in the surrounding. So first one, let's have a look what we get. We get a dashboard of vulnerabilities, software vulnerabilities, which come from SNCC in that case. So we get an overview on how severe that is, what are affecting Java, what are affecting JavaScript, and we can easily see and drill down to the ones here that are relevant. And we can go into a single violation. We see more information about that, how critical that is, what our internal class is, and we can from there jump directly, and this comes automatically, to SNCC to get a deeper view on this violation. So previously, it has been information that's been hidden in expert tools, which has not been accessible by everyone, like SNCC, like CloudDocket, where we retrieve violations, like the Azure Advisor. As I said, we are mainly running LeanIX we are running LeanIX on Azure. So the Azure Advisor is a very important input for us. Now we have all this security relevant information in one place, and this can be consumed by everyone, and it's available to all stakeholders. So this is a very important use case for us here. Second one, the lifecycle support for technologies are not endless, also not in a cloud environment. So what we get here automatically is to see where do we see a change in support, because the cloud provider tells on their websites that we see a change in support. We see also directly for this component goes out of support and see the relevant teams behind it, and also can see what is the cloud account behind that. So yeah, I mean what we see basically in this scenario is that we've seen a cloud component where there's an Azure scale set with an underlying Ubuntu operating system, and this is going out of life. So we can detect from that data what's the impact of this technology that's going out of life, and we allow our teams to take the right decisions here. So the third one here is you can see we have a high number of violations, and we want to bring them into a business context. So we want to make sure that we can only focus on those ones who are have a high impact, who are highly severe, and we also want to make sure that we can can really have an end-to-end workflow in place. So when filtering it down, you can see that out of our more than 800 violations, we come down to basically like 34 which are relevant at all, and then to 4 other ones which are relevant for a particular microservice. So this really allows us to get some very good insights into on a deeper level on what's really relevant in terms of the violation here when looking at when looking at the high number of violations that we've seen. Okay, so let me jump to the next one, which is our support use case. So in this case we've received a ticket on survey, and as you can see, the survey includes, or the support agent is in a situation where the big question is, who's the right contact person and what to do here. So the support agent directly jumps into LeanIX, can look at a matrix on and see which team is relevant, and can see that LeanIX Poll is the right microservice which is running our survey functionality. So this is basically a great help for our support colleagues, because what we have is the possibility to also see that personal data is like used, and survey results with personal data are used in this microservice. So as I said before, we've got more than 30 microservices, 7 teams which are running those microservices. So this is really an important information set to make sure that we can find fast solutions. So the next one is to give an overview on the support KPIs. So as you can see, when you look at the dashboard and you see the support KPIs, like the reaction time, the number of bugs, or the number of feature requests that we are getting overall. But the more important focus and impact is seen when we look at it from an individual perspective of a product area. For example, the inventory. So here we can basically see that that for example for the inventory, we might get a higher number of education tickets. So what does it mean in the end? We need to make sure that the functionality that we've shipped is something that didn't cause in the end more education need for a certain feature. So let's jump to the third one, which is about costs. And on costs, you can see we are able to track that on a daily basis. So costs are the overview that we get comprises all costs that we get in a multi-cloud setting. So as you can see, we can look at the costs on different levels. So where they rise on for example, the accounts, on the regions for which products they arise. So this is and what's great here, that by the integration we automatically get the costs tied to the TBM and technology categories. And we can directly see which are the big cost consumers, like which cloud accounts and which regions, and is it production or is it test instances where we are currently consuming our costs. So here is definitely was the big challenge, that we are providing this data and giving full transparency on that. The other big challenge, and this is a journey that we are on, is to bridge this to the business context. So the technology side of that is the easy part, but bringing that into a business context and rolling it further up, this is a journey that we are all together on. But most importantly, at the current point of discussion is we share the same understanding of costs, and we have it allocated and see it. In this case, infrastructure services is where we have most of the costs, and we can dive deeper. Looking at the Kubernetes service level here, we can compare the costs of the last 30 days with the current costs. We can see what kind of changes are there, which are the big cost drivers in that. And we look at a particular one, the one that causes the most costs. And we can look which are microservices are behind that. So it's the production ones, that's good. And for a particular one, like diagrams, it's, okay, Team Tornado in our case, that's behind that. So we see that this is the foundation for taking professionalized IT decisions in our setting, to see, are we investing more in stability or are we investing more in new features? And also the feedback from the team is this fosters the DevOps spirit. We are giving the data about costs, about security and so on, directly to the teams and giving the ownership there. So this has been a great step forwards here for us. So coming to the fourth one, I said we adopted the framework of Accelerate. The two KPIs that we are currently tracking is development efficiency. So as you can see, we are seeing which microservices are deployed, how often, and we also see how fast are we really in recovering severe issues on the microservices or less severe issues. So how long does it take us? So to be honest there, this is 2 out of 4. And 2 other KPIs, like the lead time and the change failure rate, that's something that also we are working on to get this into the KPI overview, and obviously turning this into these metrics into action. This fits perfectly into our own OKR process, where we, on a quarterly basis, set ourselves goals also in the development team, and to make sure that we are able to increase in efficiency there and have the right KPIs on track to keep our customers successful with our product. And also for the single microservices to track which are the mature ones. So where do we see like 0 to 1 deployments a day, like in this case Pathfinder Web, or where do we currently innovate, like workflows or the integration API, where we see 4 or 5, or the new portal, also 4 deployments a day. So there we iterate fast, we improve fast there. So let me sum it all up. Details matter in that context, as you see. So it produces a lot of detailed information, what we discover. And you've heard it from Torben. He called it the cloud CMDB. And this is a huge complexity that comes here. And this complexity needs to be managed. So we see the challenges in the cloud native world are different, but they are equally relevant for enterprise architects. So when you think about the data, it's not like in the world of with Excel lists or with manually drawn diagrams. It needs to be automated. It needs to be integrated, and it needs to be aggregated to the relevant information that can be consumed also to analyze the full picture. So what I also want to give as a takeaway here is that business context is what really makes all the information from cloud native really valuable. So this is where we add true value and see that LeanIX can play its role on really bridging the gap between the operational information, IT operational, to the IT management, to the business context, and enabling you to derive the right decisions from that. So thank you very much. I hope this was interesting for you. And if you're interested to learn more about our products, please feel free to reach out to me or reach out to Yannick Lara, who's part of our LeanIX Cloud Native Suite team. Thank you very much.
Always fantastic listening to you speak. We've got a ton of questions that have come in on the chat, and I'm hoping you've got a few minutes to answer a few of those.
Yeah.
The first one is, do you have any specific advice for people that are early on in their cloud transformation journey and some of the key challenges they should probably be on the lookout for?
Yeah, I mean, you've heard the story from Gruner and Jahr, and I think being early in the journey, that's I would say everybody is early or in the midst of that journey. I've seen only very few companies that are like super mature in this journey. So my advice is like have the right the right KPIs in place to really track. Are you spending on the right things? Do you have the right technologies in place? And I also can only refer to another customer where I loved the story to read. It was from EBSCO, who were just in the process of moving their like storage from their on-premise to the cloud, and how architecture can really drive those decisions and giving the right insights, especially when balancing it with the like KPIs, for example, performance or SLAs that the business or the customers really need. So, I mean, what's the really nice thing is that we have so many KPIs and insights, and that we can make use of them.
Great, thank you. I think we've got time for a couple more. Question here: how does CNS interact and connect with the current EA suite?
Yeah, that's a very good question. So, I mean, obviously, all what you've seen, 800 violations, or the ton of microservices that I've showed in our setting. This is nothing that you want to have in all those detail in your EA workspace. And there comes aggregation into place. This is the key to really say, for this microservice, we have 50 violations. So you're more thinking in those like numeric values. You're not listing all 50, but you give the right jump to, like, if you're interested in that, to then jump to the next one. Also on severity, is one of this 50, is it severe? So you would highlight this on the EA level and say, hey, we've got a microservice running here, which has a critical violation. So you want to just highlight it there and enable an enterprise architect to get this view on the microservice level in EA workspace to look deeper into it. But there might be others who have like 100 violations, but none of them is really relevant. So you can really, the key is about aggregating the data in the right way and make it consumable in the EA workspace. So we're talking about two different workspaces here.
Great, that's very useful. I think we have time for just one more question. And let me get that up here. And I think you may have covered this. Can you be specific about the different cloud platforms that are supported?
Cloud platforms that are supported, yes. So we are partnering here with CloudDocket, and by CloudDocket, we can do automated scans from Microsoft Azure, Google Cloud Platform, and Amazon Web Services. Yeah, these are the major hyperscalers where we can consume the cloud information from.
Great. Fantastic, Christian. So thank you for a wonderful presentation.